Hi guys, in this video I'm going to walk through this LeetCode number 19. Remove the end node from the end of the list. So let's say for this linked list, so it's 1, 2, 3, 4, 5, and then we are given a primary of 2. So that means we need to remove the nodes, the second node from the end. So the 5 is the last node, and the second from the right is the fourth one. And let's go through the algorithm a little bit to see how we can find the second node from the end. So for this particular example, we have 5 nodes. So the big N number of nodes equals to 5, and we can have a dummy node at the very beginning. So we can call it like some sort of a node 0, and then the 1, 2, the first node, second, 3, the third, fourth, and 5. And then at the end, there will be a none following the fifth one. So the problem is how we can find the second from the end. This is not a array list, right? So you cannot just see that straightforward. We have to traverse one by one each time. So so this is how I think of it. So when we are at the first node, we make one move, and then that will bring us from the first node to the second. We move the second time, and then that will bring us from the second to third, etc. So after the 5 moves, and then we will be at the very end of the node where it's a none. So n being the total number of moves, in this case is 5. That's also equal to the number of nodes. So I was asking myself, how can I know exactly? In this case, it's exactly 3 moves, and that will bring me the second from the end. So the last move, so move number n, is at the end that I'm seeing a none node, and n minus 1 will bring me the last node, and n minus 2 will bring me the second from the second from the end. And so basically this, what I need is a number of big N minus small n, right? So when I decompose, so it's basically there are first n nodes, the first n moves, and then I can do another n minus big N minus small n moves. That is equal to the total number of moves is equal to 5. So we can have 2 pointers, and the first pointer makes n moves, and it will be here. And then the second pointer starts, and then the first pointer still keep going until the end. And then that can make sure that the second pointer will move exactly n minus n moves. So let me say again. So the first pointer will move first to here, the first n moves, and then after it moves n times, small n times, and then it will stop. It will pause for a moment, and then the second pointer will start moving. So, and then when the first pointer reaches the end, the first pointer will move exactly big N minus small n moves. That's exactly how many moves we need. And then we can do the swapping. By swapping, I mean connecting the third node to the fifth node. And then we can just get rid of the fourth node. So let's look at the code and how to see how we can do that. And as I show in here, we need a dummy node to start. So the dummy nodes allows us to grab the head at the end when we return it. So we have initialized the list node. And then the next of the list nodes equals to the head. And then at the end, we will return dummy.next. So we can exactly as how can we grab the head. That's exactly how we can initialize just a dummy node. And then we need two pointers. We call it fast pointer equals to dummy.next. So a slow pointer also dummy.next. So the fast pointer will traverse the entire the entire length list, and it also will stop. It will stop after it makes n moves, and then the slow pointer will start at that point. And the slow pointer will make exactly big N minus small n moves. So let's allows us to allow the fast pointer move first. So by doing that, we allows the fast pointer make exactly n moves. So after that, we allow the second pointer, the slow pointer. So the fast pointer move exactly n moves first, and then the slow pointer start to move. Until it reach the end, until we reach the none. So while fast pointer is not none, none means it just reached the end. It will make exactly n moves, a big N, when it faces the none. And then the fast pointer and the slow pointer will move together, so that the slow pointer will move exactly big N minus small n moves. Okay, slow pointer and so slow pointer. Yeah. Okay, so this allows mix. Okay. And then at the end, after the slow pointer reaches that point, and then we can get rid of it, get rid of the ends node from the end of the list. So next, we go to slow pointer dot next. Okay. Okay, I just paused the video and pause the recording and then fix a few edge cases error. So basically, this should be dummy itself. It should not be dummy dot next. Otherwise, it will just this one becomes a non the non type. And so after fix that, and now it runs smoothly and becomes the top 10% of the. If I resubmit it again, maybe different. Yeah, 45, 45. Sometimes 90. So yeah, it's pretty efficient solution and pretty memory efficient as well. And yeah, this is my solution. I hope you like it. And hopefully see you in the next video. Bye.